Hello, we're on to section 2.2. This is really a section that I would do probably in half a class period under normal circumstances and move on to section 2.3. But I'm just going to keep this as Thursday's lesson. I believe that you guys have been introduced to interval notation. I think you know it, but it's super important in laying the diagnostics for quadratics and absolute value functions and exponential functions and logarithmic functions. I mean, so much that I need to make sure that you understand interval notation. So that's what this will be all about. And I will also be using some vocabulary called bounded and unbounded to get you ready for future math classes. So essential questions today, what is interval notation? What is the relationship between inequality notation and interval notation? And when do brackets, parentheses, and union symbols need to be used in interval notation? Now, before we get on into interval notation, I want to look at some vocabulary called bounded and unbounded. So I know this looks like a lot, and it is for a note card. So if you have to go to the back of your note card, that's fine. But this is note card 37, and it's about bounded and unbounded. Now, these first two are bounded overall, and so maybe I should make this line right here bold, because underneath that is just bounded left or unbounded left and that type of thing. Okay, so don't pause yet. I want to explain this, and then I want you to do your note card. So an interval is bounded overall if it ends on one or both sides. That means it's bounded. So this is just two examples. This graph right here, this one ends on the right, it doesn't keep going, and this one right here ends on the left. So both of those would be called bounded overall. They're just bounded. An interval is unbounded overall if it goes on forever on both sides. This particular example graph is the only time you could say something is bounded overall. If it just goes on forever on the left and the right. Up here, you'd have several instances of being bounded. I think, am I saying that right? Did I say unbounded overall? I hope I did. Unbounded overall. I mean, it's not bounded. It keeps on going. Those arrows keep on going. Up here, it's just two examples of being bounded. It's bounded, okay? Now you can go and be a little more specific. Are we bounded on the left? Are we unbounded on the left? So if you look right here, the interval is bounded on the left if it ends on the left. So on the left here, it ends. That's called bounded on the left. It would be unbounded on the right because it keeps going. This right here is unbounded on the left because it keeps going forever to the left. That arrow means it keeps going on forever. So that's called unbounded specifically to the left. Now overall, all of these on the bottom would be bounded, okay? But if you just look on the left side of this graph, it's bounded. The left side of this graph, it's unbounded on the left, bounded on the left. Now this one, if you look on the right, if we're now specifically looking at the right, it's bounded on the right. And then this one is unbounded on the right because it keeps going. So I know that might be a whole bunch for you to take in right now, and it's really a minor part of the lesson, but it's important enough that you need a note card for it. So now pause me and write down these definitions and then a quick graph. It doesn't have to be labeled with all of the numbers, but a quick graph so you can see, oh, these are number lines and this is what they're talking about. So pause me and get that done. All right, so now we're going to move on to interval notation. So interval notation is a way of writing subsets of the real number line. Another way to say it is a way of writing down a set of numbers. So again, I think you guys have seen this. I think you know how to do this, but just in case you don't, we're going to go over it. So for a closed value, you're going to use brackets. For an open value, you're going to use parentheses, and you can have a mixture. You can have a half open, half closed mixture. And if you have more than one interval, you'll use a union, okay, to write the different subsets. And we're going to go over all of this in today's lesson. Hey there. All right, so I just wanted to show you, before we actually do some examples on note cards, I wanted to show you a couple of these. A closed interval, of course, is when you have they're closed, the numbers are included. And up here, I put for a closed value. Well, you need to know what that means. So this is interval notation. See, it's got the -3 is less than or equal to x, is less than or equal to 1. That means that x can take on values -3 to 1 inclusive. So that -3 and that 1 has the equal to, so they're included, they're closed circles. So that's the interval notation. Okay, one of the essential questions was how is that related to, I'm sorry, that's the inequality notation. How is that related to interval notation? Well, you would just write this, you go left to right when you're doing interval notation. So it starts with -3, and it's a bracket because it's a closed circle, and comma means a span. So it spans all the way to 1. And it's another bracket because it's a closed circle. Let's look at this one. -3 less than x less than 1. X is between -3 and 1. And there, it's not included. These values are not included, so those would be open circles. Again, this is something, these number lines, that you've been looking at inequalities like this since probably 7th, maybe even 6th grade. So don't overcomplicate this. You're used to this notation. You just haven't seen it in a while, possibly. And you're used to graphing them. All right. These are open circles. So for interval notation, remember you go left to right. So -3 with a parenthesis because it's an open circle. Parentheses correspond to open circles. So -3 comma means span. So span all the way to 1. And that 1 is an open circle, so it's going to have a parenthesis. This looks like an ordered pair, but it's not. You have to consider the context. So yeah, you could easily think, oh, that's the vertex. No, this is interval notation. And you may be wondering, why are we doing this? I know I said it earlier, but y'all, tomorrow in the next lesson, we're doing diagnostics. This is huge. Domain, range, negative, positive, decreasing, increasing, and you have to write all of that in interval notation. So that's why we need to make sure we understand how to write interval notation. Here's another example. So you can have intervals that are half open and half closed. So if you look from left to right, it's bounded. It's bounded both sides, bounded overall, bounded on the left, bounded on the right. All right, so we start with -2, but that's a closed circle, so it has a bracket. The comma is a span, so it spans all the way to 4. That would be an open circle, so that is a parenthesis. Now, what if we have several things going on at a time? Oh, goodness. All right, so right here, I know that's really hard to see, so you may need to zoom in. If I try to zoom in, it goes to the next slide. And if I try to zoom in using the little mini waffle 3 things at the top, it actually makes it smaller, so it's really bizarre. But look, I have 1, 2, 3, 4 things happening. It was bugging me, so I had to fix it. Okay, so I know it's a little blurry, but we can see it better. So we have this, and it goes from -4 to -2, closed circles. So those will be bracket, -4, comma, which is a span, all the way up to -2 with the bracket. Then it jumps, and this is where we do this union symbol. It's like just a capital U, a little bit wider than you normally would write a U. Not going to be that nitpicky about it. But then it starts at -1. It's an open circle, so that's a parenthesis, and it spans to this 1. And you might go, well, it goes to 2. That's an open circle, so we have to stop. Okay, so be -1, comma, or span to 1 with an open circle, so a parenthesis, then a union. And so we got to pick right back up at this 1 because that's not included. And I know this is tomorrow's lesson, but that's not part of the domain, so we have to split it. So we'd have a union, and we'd have a parenthesis again at the 1. So we're looking right here, spans to 2, so comma 2 with a bracket, because that's a closed circle. And then this is just a singular point. When that happens, there's no span. So you won't have a comma. You really won't have commas and brackets, but you can write it like this. Another thing is you could, because it's a closed circle, you could put square brackets around that. I know that's a whole lot, okay? So I hope that it makes some sense, but we're gonna go to an example in a minute, example note card in a minute. I've got this here and I'm gonna go to this and you guys can practice as well. It's in the notes. And there's this little quiz here, and so it won't count for anything. It's not like that. Okay, so how would we write this? Now, on the examples I just did with you, we had graphs, and here we don't. So this is just x is between 5 and 11. Are there equal to's? No. So they're not included. They would not be closed circles. So it would be this. And after I finish this little quiz, it'll tell me if it's right or not. Now look, this is between 4 and 9. The 4 is not included, but the 9 is. So that would be a parenthesis on the 4 and a bracket on the 9. All right, here, the 3 and the 12 are both included because of the equal to's. So it'd be brackets on both. This one, the 2 is included, but the 7 is not. So it would be C. And just so on. I'm going to end the quiz, and it told me that all of those were right. Now, if I got them wrong, it's going to tell me the right answer, so I can always go back and try that quiz again. The next thing I want to do is look at the delta math. You are going to have questions on delta math, so this is a particular question that you may or may not see, and I just want to go over it with you. All right, so it says, graph the interval represented in the inequality notation, on the number line. So this is inequality notation. This is an or. We don't have it all smushed together with the variables in between. So this is where the graphs would go away from each other. So x is less than or equal to 10. Now this tells me right here, click and drag. So I'm going to go, I'm sorry, that's negative 10. I'm going to go to negative 10, and I'm going to drag this way because, oops, it says x is less than or equal to that. So it's a closed circle. If it were an open circle, I would have to click the circle. It tells me that right here. And then it has, or x is greater than or equal to negative 6. So I'm going to go to negative 6 and go like this. Remember, or problems, they run away. This is old stuff. This is not Math 2 stuff. You've done this before. And I'm going to click submit. I'm going to keep my fingers crossed, hope that it works, and it did. Now let me go to a new problem. Okay, this one says express the interval shown on the number line in inequality notation. So this is old school notation, not interval notation. These are running away from each other. So let's see, x has to be less than or equal to 0. So x less than or equal to 0. And then I put or, what is it? X greater than or equal to 10. And I know that's got the equal to's on them because they are closed circles. I hit submit, keep my fingers crossed, hope it's going to work out, and it did. Let me see here. Okay, now this one says graph this one on a number line. So this is where the x is in the middle, so it'd be between 5 and 8, not the running away, not the arrows going away from each other. So I'm going to go to 5, and I'm going to make it go to 8, and these have equal to, so those are closed circles. I submit, fingers crossed, yes. Okay, this is one, it has an or, so they're going to go away from each other, and there's not equal to's. So x is less than negative 9. I'm going to go to negative 9 and just go on. But I got to click that. It's got to be an open circle because it doesn't have an equal to on it. Then I go to 5 and go like that because x is, no, not that. It's negative 5. There we go. Oh, okay. Let's see. I'm going to start over. It wouldn't let me drag it over. So the frustrations of delta math sometimes. So I go to negative, okay. And then x is greater than negative 5. Okay. And both of them are open circled and good to go. All right. So I wanted to go over that. The next thing, the next type you're going to see is this. It says graph this interval notation. So this is interval notation. It has a bracket and it's a span. The comma is a span. So I go negative 6 to negative 2. There's brackets, so they're both closed. Okay, what about this? Negative 10 to infinity. So that means it's going to go, remember that number on the left is where you start, and it goes on forever. It's unbounded to the right, it's bounded to the left. It has a bracket, so that's a closed circle. If it were open, it says click the closed circle to change it to an open circle. But this one's not that. Let's see, let me see. Okay, so this one, negative 7 is where I start, and I go to negative 1, and the negative 7 has a parenthesis, so that's open, and the negative 1 has a parenthesis, so that's open. Okay, so I wanted to show you that, and the next section looks like this. Express this in interval notation. So left to right, it would be bracket. That would be a bracket because it has the equal to. And this would be a bracket. So it would be a bracket and a bracket. And it'd be 1 span to 9. Okay. Now this one's different. Think about what the graph would look like. Think about what the graph would look like. I got my handy dandy document camera. And this is an or, so they run away from each other. So if I were to graph this on a number line, now I don't sit here and draw all the tick marks, and you wouldn't have to either. I would want 0, and then the numbers that are in question. Okay, so x is less than or equal to -9. That would go like this way. And then x is greater than or equal to 1. Close circle, it would go this way. That's what the graph would look like. So what would the interval notation be? We would have, there's 2 sets, so we would have a union, okay? Because there's 2 separate shaded areas. Now I start from the left. This is negative infinity. Around infinities, you never put brackets, ever. Because they're not tangible. You can't like grab them. They're not an actual thing because it's a concept. It means it goes on forever. So negative infinity to -9, it's a closed circle, so bracket. And then there's a big jump to 1 with a bracket because it's a closed circle. And then span, so comma, to infinity because it goes on forever. This is unbounded on the left and it's unbounded on the right. Now overall it's bounded because it doesn't cover everything. Okay, so now I'm going to go back to Delta Math and type that in because it wants the interval notation. So I'm going to have a parenthesis and a bracket because I wrote down what I needed. Negative, oh, it has a negative infinity option. Good. So negative infinity to -9, and then or, now I put a union. They're using the word or on this one. Or, and then it's a bracket and a parenthesis. So 1 span and then infinity. Okay, so the or is fine, and this is not giving me, oh, I could put a union. There's a union. Let me do that. I just want to do that. You could put the or if you're doing inequality, but we're doing interval, so we need the union there. We hit submit answer. We cross our fingers. Heck yes. Okay, let's do a new one. Okay, what about x greater than 8? What would that graph look like? X greater than 8. Well, we would go to 8. So on the number line, it goes on forever. I like to have a 0 on there, and then I would put the number in question. So I'm going to put an 8. And then this is x greater than 8. So at 8, I'm going to put an open circle, and then I just shake this way to the right, x greater than 8, like 9, 10, 11, 100. And what would that interval notation be? Well, I don't need a union because there's only one shaded area. Now I start left, and that would be 8, and that would be a parenthesis because it's an open circle. So 8 spans all the way forever and ever to infinity. So look, this is bounded on the left, it's unbounded on the right. Now, it's bounded overall because it doesn't cover the whole number line. Go back here. I've got 2 parenthesis sets, 8, and then I put infinity. I go to submit. I hit yes, fingers crossed, yay. All right, so we could just keep going on and on. There's one more. The last thing on this assignment got all 3 representations, but I wanted to go over the Delta Math so that you could see what types of problems you will have. All right, so once I'm finished with this, I'm going to upload this on the slides and give you time to write this down. But this will be note card 39. It's an example of inequality and interval notation with a graph, all right? So if I give you this graph, and again, I don't have to have all the little tick marks. You don't have to. Okay. So open, closed. All right, and I'm shaded in between. So what is the inequality notation? Old school, what you've seen for years. Well, it runs in between. So you know that the variable is going to be in between. And it starts at -2, it goes to 3. Now, we surround it by less than or equal to's. So here would be just or just less than's, because at the -2 it's an open circle, and at the 3 it's a closed circle. So that's the inequality notation. The interval notation is we still go left to right, and we have a span. So it'd be parenthesis -2 because that's an open circle, span, so comma, and then 3 with a bracket because that's a closed circle. All right, now again, I will work this with you and then I will put it nice and pretty on the slides. So just wait and fill this out in a minute. So I don't know that I gave you time. Hold on a minute. Did I have you finish this? There you go. There's note card 39. So if you haven't already finished it, pause me and finish it. Pause, pause. All right, so I'm getting ready to go over note card 40. I'm going to work it on the document camera, then upload an image here on the Google Slides. Okay, so this is with more than one set. So let's say we had this happening. Got a little froggy there. All right, so let's do some shaded that way, and then shaded there. And then shaded that way. So I have 1, 2, 3 sets. So I will need a union in my interval notation. And we're not going to do this one in inequality notation. This is really just for the interval notation purpose. All right, so let's start with the leftmost set, and you start on the left. And that would be negative infinity, because that goes on forever to the left. Over here on the right would be positive infinity. That goes on forever to the right, positive. So left to right, be parentheses, negative infinity. Remember, negative infinities never have brackets. They're not actual closed circles because they go on forever. All the way to -4 with the bracket. So this is negative infinity to -4. It spans to -4 with a bracket because it's a closed circle. Then there's a union because there's a jump, a change, okay? A change in the domain. So then it would go -1 to 0, so -1 comma 0, but the -1 would have to be a parenthesis because it's an open circle. So -1 comma or span to 0 with a bracket because 0 has a closed circle. And then another union because we have a break in the domain, okay? And then parentheses 2 because that's an open circle, spans forever. So to infinity with a parenthesis. All right, I'm going to take this, I'm going to pause myself, put this over on the slides. I'll be back. All right, so I went in and put it all here for you. Given this graph, what would the interval notation be? Note card number 40. So pause me and get that finished. All right, so note card number 41 is just another example, another type. I went over one like this where it was in between the two numbers. So I want to do one where it's a little different. Okay, so note card 41. Again, I will give you a chance to get all this written down here in a minute. So just watch. All right, so x is greater than 1 or x is greater than or equal to 4. This is in inequality notation. This right here is in inequality notation. Okay, so I want you to write this in interval notation. Now, a middle step is to graph it. I think graphing it's important so you can see what's going on. But if I just ask you to put this in interval notation, you don't necessarily have to graph it. But guys, if you're getting it wrong, you should graph it, okay? Okay, so I always like to put 0 and then I added the numbers in question X is less than 1, so that would be this way, an open circle, and it would go on forever. All of those values are less than 1. Or X is greater than or equal to 4. So I've got a closed circle at 4, and it would go this way. There you go. That's the graph, if you were asked to graph. And what is that in interval notation? We start left to right. Keep in mind, this is unbounded on the left, so that's negative infinity. And this is unbounded on the right, so that's infinity. So we go left to right, negative infinity, no bracket there, parentheses, span to 1 with a parenthesis because that's an open circle. And then we have a union because it splits the domain up. So union, bracket 4 because the 4 has a closed circle, span or comma to infinity, parentheses. That's no part 41. All right, so here it is. Get that written down. Thank y'all for paying attention, doing what you're supposed to be doing. And I can't wait to get to the next lesson. Bye, guys.